Good morning. This is Dr. Vijayakumar, Head of the Department of Physics, SNS College of Engineering. The another one topic we discussed in new engineering material, bottom up process. The previous video we discussed in top down process. This has become bottom up process. The example of bottom up is a physical vapor deposition method that we call as a thermal evaporation method. So the physical vapor deposition method is a common method. It's one of the simplest form and typically used in a resistive heat source to evaporate the solid material and atomic levels. So is in a high temperature we have applied ultra high vacuum range we form, then it's created in the atomic level. In vacuum environment to form in a thin film. A material is heated in a high vacuum chamber until vapor pressure is produced. So physical coating process involved in condensation and evaporation. So these two processes we form in that PVD. PVD is used for high melting point and low vapor pressure materials. It is an alternative process of electroplating. So the physical vapor deposition, the evaporation, arc vapor deposition, ion plating, then sputtering. Then assignment, what is the difference between physical vapor deposition and chemical vapor deposition? Why vacuum is created in a chamber before thermal evaporation? What is meant by PVD coating? So this is all the questions we get the answer from the end of this session. Physical vapor deposition is a form of gas phases, that is a transport. Then we get in a gas phases, then it's a form of condensation. So the condensation phase is usually in a solid, but the starting phase is in a condensation. It's a form of solid or liquid. It starts from the evaporation, then to change from gaseous phases. So this is a chamber of PVD. The substrate is a glass material, that is an insulated material. The above of the substrate is form of a thin film. That is the material we form in the evaporation. So we given a high temperature from the lower, the upper is an ultra high cooling form. The inside we used in argon gases that we act as carrier gases from this chamber. Inside the initially to the form of ultra high vacuum ranges of 10 power minus 7 millimeter of mercuries. Then the sputtering gases to be formed in that inside after that. So the evaporation atom to be interacted from in argon atoms, then it will be deposited from in the upper target of sputtering. So the evaporation chamber is filled with an inert gas. The metal vapor migrates from the source into the cooler insert gases. The evaporation atom collide within a gas atom and to be deposited from in a substrate to losing of its kinetic energy of moving atoms. So the metal vapor cool through the collision and inert gas species of supersaturated formation. The homogeneous with the particle size is 1 to 100 nanometer. The particle size is controlled by the inert gas pressure. Particle collected on a cold finger by using in a liquid nitrogens. So the types of carrier gases is used and temperature of the gas used, evaporation temperature, source to substrate distance. This is all the very important factor we followed from this procedure of PVD. Then advantages, the environmental freely done in a paint and electroplating. More than one PVD techniques can be used for coating. Usually top coats are not required. The good strength and durability to the form of this method. The disadvantages, the cooling system are required. The mostly high temperature and vacuum control needs skill and experienced personality to be handled with this device. Then PVD coated material has no chemical interaction with a surface. Thank you very much. This is a reference I am prepared from the PPT to the form of PVD in a bottom of process. Thank you very much. We discussed in another one topic in another one video of this new engineering material. Thank you.